science breakthrough. Researchers find a new way to search for extraterrestrial life. They've created a chemical reaction using a cyanide that could have triggered organic life to form on Earth 4 billion years ago. Cyanide, as we know, is a very deadly chemical for us. It can exist in various forms, and it has seeped into popular culture over years through film and fiction. Spies opening an empty, odorless envelope, only to die hours later in the most common scene. Cyanide deployed by directors, playwrights, and authors. As Karen Smith, senior research scientist at Boise State University, noted a few years ago, she said, when most people think of cyanide, they think of spy movies, a guy swallowing a pill, foaming at the mouth, etc. But cyanide was probably an essential compound for building molecules necessary for life, she says. So indeed, new research found that this lethal compound could in fact have helped life to evolve on Earth. And what's more, looking for signs of it on alien planets may help us to locate life elsewhere in the universe, according to chemists at Scripps Research and what they found. The team discovered that the compound, which contains a carbon atom bonded to a nitrogen atom, could have enabled some of the first metabolic reactions on Earth that created carbon-based compounds from carbon dioxide. Metabolic reactions are these reactions that create energy out of food and are essential, of course, for sustaining life. The researchers spoke to BBC Science Focus magazine. In its piece, cyanide may have played a key role in the origin of life on Earth, and it could help us find E.T., they said. Dr. Ramanarayana Krishnamurthy, Associate Professor of Chemistry at Scripps Research, was a study's lead author, and he said, when we look for signs of life, either on early Earth or other planets, we base the search on the biochemistry we know exists in life today. And the doctor said, in fact, these same metabolic reactions can be driven by cyanide, shows that life can be very different. And to make the discovery, the team homed in on a set of chemical reactions that combined carbon dioxide and water. This was intended to create a more complex compound, the compounds that are necessary for life known as the reverse tricarboxylic acid or RTCA cycle. This cycle is used by some bacteria that currently exist on our planet, but it also relies on the use of complex proteins that had not yet formed on the planet during its infancy 4 billion years ago. So we can understand how Earth has changed and life on Earth has changed, chemistry has changed. Now, previous studies have shown that certain metals can trigger the same reactions under extremely hot and highly acidic conditions, but the Scripps team had a hunch that another chemical compound may also be able to do so, only under the less extreme conditions seen on early Earth. Because they already knew that cyanide was present in the atmosphere back then, they were able to map out a set of reactions that could potentially use cyanide to produce more complex organic molecules from carbon dioxide, and later tested these in the laboratory. Dr. Krishnamurthy said, "It was scary how simple it was. We really didn't have to do anything special. We mixed together these molecules, waited, and the reaction happened spontaneously." So it's a hopeful sign in figuring out how biology came to be on Earth, given that once our planet was filled with only non-biological chemistry. Unfortunately, the experiment does not offer conclusion proof that cyanide was involved in the process on our early Earth, but it does offer a fresh way of thinking about origin of life, and according to the researchers, it perhaps provides new means of searching for life on other planets. It's not the first time scientists looked into cyanide and found interesting results. In 2019, a study suggested that meteorites laced with iron, cyanide, and carbon monoxide, another deadly compound, would have helped early life on the planet. And it offered what were at the time new insights, for example, that cyanide and carbon monoxide linked up with iron to create stable compounds of iron cyanocarbonyl complexes, similar to certain structures on those vital hydrogenase enzymes. This is on Express UK by Joel Day. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.